Welcome to 6B, solving systems of equations. Last section, 6A, we solved them by graphing. This section has another method for solving them. Like most math problems, there's more than one way to work it. And depending on the situation, one method may be quicker, faster, easier than the other. So last section we graphed two equations. We saw where they intersected to find the solution for inequalities. We saw where their regions were the same. And this section, we're going to actually not graph the lines. We are going to solve them using another method called substitution. So you won't see us graphing, I don't think. Let me take a peek here. In this section, this is all just working using the equations and using the method called substitution. So I'm not going to go through this flow chart right now. I'll let you read through it. I think it will make more sense actually after you've worked some problems, and then you go back up and review what it is they're telling you here. So let's just get down to this example 1. If we were doing this like we did in 6A, of course, we'd be getting both equations into y equals mx plus b form. We'd have a coordinate plane over here. We'd be graphing. We'd be seeing the place where the two lines intersected. But there are other ways to do it, and sometimes graphing doesn't work so well, especially when you're dealing with weird numbers and fractions. You can't really see where they intersect. If it's not perfectly on a coordinate that you can identify, you don't have your answer. So the other methods can take care of those problems. So we're first going to figure out how substitution works. And you are going to look, I'm going to write this down, look at both equations and see if you have one where you have a variable with no coefficient. So let's look over here. Well, in this top equation, the x has a coefficient, it's 7. The y has a coefficient, it's -2. Down here, the x has a coefficient of 2, but the y has a coefficient, but it's 1. So I guess I should say a variable, because every variable has a coefficient. Variable with a coefficient of 1. So we have found him, there he is, and we are going to take him, and we are going to substitute his value into the y in the top equation. Because if y is equal to 2x plus 1, if both sides of these represent the exact same thing, then we can use y, or we can use 2x minus 1 and have the same value. So if you look at our original equation, 7x minus 2y equals 11, I am going to replace this y right here. I'm going to substitute the other side of what y really equals and put him in place of y. So when you do that, you get 7x minus 2, and now instead of times y, I'm going to write this as 2x minus 1. This is replacing or substituting for y. And why, you might ask? When I do this, now I have all x's. I don't have two variables, and I can solve for x. So clearly I can distribute, and I get 7x minus 4x plus 2 equals 1. That's nice. Or 11. I left off my 11. Come down here, collect my like terms. I've got 3x plus 2 equals 11. Subtract 2 from both sides. 3x equals 9. Divide, and you get x is equal to 3. So that's nice. Now we know one of our 2 points. That's our solution set. Now that we have 1 point, we can take this x equals 3 and we can plug it back in either of these 2 equations to solve for y. So let's go to the easier looking equation. Y is equal to 2x minus 1. Oh dear. Coming back. So y is equal to 2, and in place of x, I'm going to put in the value that we found for x, which is 3. Y is equal to 6 minus 1. Y is equal to 5. So I think that my ordered pair is 3, 5. I think that this is the solution of my equation, but I'm going to prove it. So I am going to take this ordered pair and I am going to plug him back into the equation I did not use finding the value for y. So 7x, let me do him in blue. 7x minus 2y equals 11. When I plug in for x and I plug in for y, I should get 11 after I do this arithmetic. So let's see what happens. I think x is 3. I think y is 5. 7 times 3 is 21 minus 10. Is that really equal to 11? Yes, 11 equals 11. So this guy right here is the solution to my equation. This would have been the exact point where our lines crossed had we done it by graphing, but instead we learned a new method and we've done it by substitution. Okay, let's do one more on the top of page 60 before we stop this video. Here are our two equations right here. This is our system of equations, and we need to solve them by substitution. So first thing I want you to notice is that this is y equals and this is y equals. So that means that these two guys are really equal to each other, because I'm saying that if I did this numerically, I could say 12 is equal to 10 plus 2, and I could also say 12 is equal to 6 plus 6. Well, that also means that 10 plus 2 is equal to 6 plus 6, because both of these equal the same thing. So I'm going to use that idea with these, and I'm going to say, okay, 1/3 x minus 5 equals his partner down here, because they both equal y. So once we've set these two equal to each other, now we can solve for x. Let's clear our fractions. Let's multiply everything through by the LCD, the lowest common denominator, and I'll get 2x minus 30 equals x minus 18. Get your x's together, subtract x from both sides, and we get 1x, or just x, minus 30 is equal to minus 18, or x is equal to positive 12 when we add 30 to both sides. Again, we've got what we think is the first coordinate of our ordered pair. We need to find what the y is, and we can do that by plugging it in either one of these equations. So I'll just pick this one. I'll say y is equal to 1/3 of 12 minus 5, which is 4, minus 5, which is minus 1. Right there. Now I'm going to prove it. One last little step. I'm going to go use this equation now, that guy, because I used him to solve for y, so I don't want to use him again. I want to use this guy and plug in both the x and the y to make sure that this makes a true statement. So we think y is minus 1 when x is 12, and we want to figure out, are these guys going to be the same number after we do the arithmetic. So is negative 1 equal to, well, let's see, this is 1 times 12 is 12 divided by 6, which is 2. So negative 1 is, in fact, equal to negative 1. So we have about proved every which way possible that this guy right here is our solution set. Sound good? All right, I do want to run through a couple more examples, because we've got a couple examples that are exception type equations, and we'll do that on the next video. Thanks for watching.